Alright, let's move on to number 3 out of the more proofs with CPCTC. Now I'm going to make a note here that my speed is going to increase, but you guys have this on video, so feel free to pause it, let it soak in, replay it. But I'm not going to spend as much time developing these things. I just want to go through them so you get familiar with them, okay? So, the first thing I'm going to write down is my givens. Kj is, this should have been parallel, is parallel to Mn. Segment Kj is also congruent to segment Mn. And L is the midpoint of segment Jm. There's my givens. Get ready for step 2. But first, let's mark my givens in my figure and do a little brainstorming. Kj is parallel to segment Kj is parallel to segment Mn, which means that the lines are also parallel. But here, segment Kj is congruent to segment Mn, and I'm told that L is the midpoint of Jm. It doesn't let me mark anything specifically yet, but I could use that statement to mark segment JL congruent to segment LM. And I could say then that my first item that I could brainstorm and I could outline and see here is segment JL is congruent to segment ML. May have misspoke a minute ago. Segment JL is congruent to segment ML because of the definition of midpoint. Now, I'm looking at this triangle, these two triangles. If I'm going to try to prove that this distance KL is the same as distance NL, I need to be able to show that these two triangles are congruent first. If I'm going to show that these two triangles are congruent first, I need to have one of my shortcuts satisfied. Looking at it right now, I can jump on and know that these angles are vertical angles. So I could name angle ALJ is congruent to angle NLM, because vertical angles are congruent. It's definitely a true statement. Excuse me. However, I have 3 items in each, but let's take a look at what I have. I have side, side, angle, side, side, angle. That doesn't help me. It is not a congruency shortcut. So I'm not there yet. What else can I do? I know that these two are parallel, which lets me use any number of transversal relationships. Let's just choose one and go with it and see where we're at. Let's say that angle KJL is congruent to angle NML. And that would be because they are alternate interior angles. And alternate interior angles are congruent. If those lines are parallel, obviously. You could also say alternate interior angle theorem. Now that I have that, let's see, what do we have out here? We have a side congruent to a side. Those are corresponding. We have an angle, not an S. We have an angle corresponding to an angle. Those are congruent. And we have a side corresponding to a side. Now we could have gone the opposite direction, and we could have used the vertical angle and the fact that these two are alternate interior angles, angle JKL and angle MNL, and that would have given me side angle angle. So if you went that way, there's more than one way to skin a cat. There's more than one way to do these proofs. I'm going to stick with this method. Angle KJL is congruent to angle NML, and that opens up for me side angle side shortcut. So now I can make the statement that triangle triangle KJL is congruent to triangle NML because of side, angle, side. Now what does that do for me? Does that help me get closer to what I'm trying to prove? Certainly it does. It opens up the door. I can now use CPCTC to state that side KL is congruent to side NL. So now I can say that this side or segment KL is congruent to segment NL. And let's go ahead and let's start writing our proof out. We'll go through the steps that we need to have. We need to have this one. We didn't use the vertical angles for ours. We did use the alternate interior. We did use the triangle congruency shortcut side, angle, side. And the reason down here for our last statement is, well, CPCTC, the corresponding parts of congruent triangles are congruent. So let's start to write it out in our proof. I need the first one. JL is congruent to segment ML, so segment JL is congruent to segment ML. And we knew that because of the definition of midpoint. I can skip my vertical angles. It's true, but I don't need it in my proof. If you put it in your proof and it's true, you don't use it, it's okay. It won't be marked wrong. But we're going to keep it clean here. We don't have to have it for the way that we prove this. The next one was angle KJL is congruent to angle NML, and I knew that because alternate interior angles are congruent. Or we could have written alternate interior angle theorem. And for number 4, we need to have that once we have these statements, we know that triangle KJL is congruent to triangle NML because we have a side, an angle, and a side. And where did that first side come from? The first side came from step 1 in our given. The angle that we had came from step 3, and the second side that we had as congruent came from step 2. So we have side, angle, side from step 1, step 3, and step 2. Carry my line down a little bit here. Once we knew that those triangles were congruent, we could then say that segment KL is congruent to segment NL because corresponding parts of congruent triangles are congruent. And I should be done now, right? Let me double check that my last step corresponds with, wait a minute, with my proof statement. My proof statement needs to be that KL equals NL. Right now I have segment KL is congruent to segment NL. I need to add one more step here, ladies and gentlemen. I need to say, in order to say that KL equals NL, I can say it, I'm ready to say it, but what's my reason have to be? Well, I know if two segments are congruent, then their measures are equal. So my reasoning for that is definition of congruence. And there you have it, ladies and gentlemen. A little more involved, a couple extra steps in there. Make sure that you line things out appropriately. And just to recap, this is not the only way that we could have gotten there. We could have used the vertical angles and these alternate interior angles. It would have just needed a couple more steps in the proof.